So we want to start by sketching an equilateral triangle, and that means that all three angles are of course 60 degrees, and it's an equilateral triangle, so all three sides must be the same length. We're going to say that all three sides are of length 2 units. Now, the next thing we do is bisect this triangle into two equal halves, so we have two right-angled triangles. This now gives us a right-angled triangle, and we're going to focus on the sides of this triangle. Now, the hypotenuse is 2. The base is, of course, half of the original base length, which is 1, and we can calculate the length of the third side, which we'll call x, using Pythagoras Theorem. X squared plus 1 squared is equal to 2 squared. So x squared is equal to 2 squared minus 1 squared. That's x squared is equal to 4 minus 1, or 3, which gives us x is equal to the square root of 3. So this third side is equal to 3. Now, we are going to focus on using this angle here, the 60 degrees in the bottom right-hand corner. And we're going to think about writing down the sine, the cosine, and the tangent of that 60 degrees. So we're going to focus our labelling on this angle and this angle alone, the one highlighted in green, the 60 degrees. We know that this is the hypotenuse. This side here is the opposite. You can see it's directly opposite that angle there, and then that leaves the 1 as the adjacent. Now, if I want to work out the sine of 60, we know that's equal to the opposite divided by the hypotenuse. We can, if we need to, remind ourselves of our trig triangles. So the sine of an angle is equal to the opposite divided by the hypotenuse. So the sine of 60 is the opposite divided by the hypotenuse, which is root 3 divided by 2. And you can check that on your calculator. Input the sine of 60 and you see that you get the square root of 3 divided by 2. Now, the cos of 60, well, let's remind ourselves, the cosine of an angle is equal to the adjacent divided by the hypotenuse, which is 1 divided by 2. And then the tan of an angle is equal to the opposite divided by the adjacent, which is root 3 divided by 1, or root 3. And we can check all of these values on a calculator. But really interesting because it shows us that the sine, cosine and tan of 60 are all exact values. So that means they're not just long decimal numbers, they can actually be written in an exact format. Now, we're going to take the same right-angled triangle, which is again half of the original equilateral triangle again, but this time we're going to focus on the other angle. So we're going to actually ignore this 60 degrees here. And in fact, as you can see, I'm going to rub it out so we don't think about labelling the sides from that perspective. And instead, we're going to use the angle up at the top here. Now, if one angle is 60 and the other angle is 90, then because the angles in a triangle have to add up to 180 degrees, this angle has got to be 30 degrees. Now, if we're labelling the three sides of the right angle triangle based on the perspective of this angle, then a few things change. Now, the hypotenuse remains as h, but it's this side that's now the opposite to the 30-degree angle, and this side is the adjacent over here. So remember, we're basing everything from this 30-degree angle. So again, using the rules as we did last time, we can write down the sine of 30, which is the opposite divided by the hypotenuse, which is 1 over 2, or a half. The cos of 30 is the adjacent divided by the hypotenuse, which is root 3 divided by 2, and the tan of 30 is equal to the opposite divided by the adjacent, which is 1 over root 3. Now, with this last example, 1 over root 3, we can actually rationalise the denominator of this. So, multiply the numerator and the denominator by root 3. It's good revision of our surds knowledge, and this gives us root 3 over 3. Now, if you input these three values into your calculator, you will see that sine 30 is a half, cos 30 is root 3 over 2, and the calculator will return for tan 30 root 3 over 3. So that's really interesting because we now know for 30 degrees and 60 degrees some information about the sine, the cosine and the tangent. So what do we know? We know that the sine of 30 is a half, the cos of 30 is root 3 over 2, and the tan of 30 is root 3 over 3. Now, we also know that the sine of 60 is root 3 over 2, the cos of 60 is a half, and the tan of 60 is root 3. Look at the fact that we get this interchange over here for the sine and the cosine of 30 and 60. And thinking back to the right angle triangle, you may be able to explain why that is. We're now going to look at an isosceles triangle. The isosceles triangle is going to have one angle of 90 degrees, so it's a right angle triangle, which means that the other two angles, by definition of the fact that the triangle is isosceles, have got to be 45 degrees each. I'm going to define two of the sides as 1 unit each, and then the third side, the hypotenuse, well, if we calculate 1 squared plus 1 squared, that's equal to 2, so that means that the third side must be length root 2. So if x squared is equal to 2, and let's say x is the hypotenuse, x is equal to the square root of 2. Now, it doesn't matter which of these angles we pick, they're both the same, 45 and 45, we'll get the same results. I'm going to pick this 45 degree angle over here. So to avoid confusion, even though I will get the same results, I'm going to actually rub out the other one so that we don't spend too long thinking about it. There we go. Now, let's label up the sides of the triangle. So the hypotenuse is, of course, this one. So opposite this 45 degree angle is this, and then this is left to be the adjacent. Because the opposite and the adjacent are the same, you can see if we'd use the other 45 degree angle, we'd get the same results. So let's remind ourselves that the sine of 45 is the opposite divided by the hypotenuse, which is 1 over root 2. So multiply by root 2, multiply by root 2 to rationalise the denominator, and we get an answer of root 2 over 2. The cos of 45 degrees is the adjacent divided by the hypotenuse, which is also 1 over root 2, and we now know that's the same as root 2 over 2. And the tan of 45 degrees is the opposite divided by the adjacent, which is 1 over 1, which is 1. So we now have the exact trig values for the sine, cosine and tangent of 45 degrees. So we can summarise these results in a table. So we know that the sine of 30 is a half, the cos of 30 root 3 over 2, and the tan of 30 is root 3 over 3. We know that the sine of 60 is root 3 over 2, the cos of 60 is a half, and the tan of 60 is root 3. We've also just discovered that the sine of 45 is root 2 over 2, the cos of 45 is also root 2 over 2, and the tan of 45 is 1. Now, using our calculators, we can then work out the sine of 0, which is 0, the cos of 0, which is 1, and the tan of 0, which is also 0. We're also going to calculate the sine of 90, which is 1, the cos of 90, which is 0, and the tan of 90, which does not exist. Your calculator will return a math error. Now, you need to memorise all of these exact values. So let's have a look at how we can now complete some examples. All of these must be done without using a calculator. So we're going to find the value of x here. Now, let's start by labelling the triangle. So the hypotenuse here, the opposite here, and then the adjacent here. I'm going to highlight the two sides that I'm interested in first of all, and I'm trying to find out this one, and I've been given this one. So that means we have O and H, which means this is a question about sine. So we have this result here, and we're trying to calculate O. So the opposite is equal to S times H, or sine 30 multiplied by the hypotenuse of 12. And we now know, if we confer with our table of values, that the sine of 30, of course, is a half multiplied by 12, and that is, of course, equal to 6 centimetres. Let's now look at example number 2. I'm going to start by labelling the sides. So the hypotenuse is x, the opposite is here, the adjacent is here. So let's highlight the sides that we're interested in. We're interested in calculating h, and we've been given a. So this is clearly a problem that involves h and a, so it involves the cosine, or ca. Now we're trying to calculate h, so covering that up, h is equal to a divided by c, so that's 10 divided by cos of 60. Now this is where, rather than writing a nested fraction in the denominator, fraction of a fraction, I would write 10 divided by cos 60, and that's 10 divided by a half, which is the same as 10 multiplied by 2 over 1, which is the same as 20 centimetres. Let's look at example number 3. Again, let's start by labelling the hypotenuse, the opposite and the adjacent. And we're trying to calculate h. We've been given a. So we know that this is a problem that involves a and h and cosine, CAH. Let's cover up what we're trying to calculate, h, which is a over c. So that's 12 divided by cos 30. And again, with the division, I'm just going to be a bit more careful. I'm going to write 12 divided by cos 30, which is 12 divided by root 3 over 2, which is 12 multiplied by 2 over root 3. Thinking about how we divide by a fraction, we take the reciprocal of the second fraction, so root 3 over 2 becomes 2 over root 3, and we change from a division to a multiplication. And then that's 12 over 1 multiplied by 1, 12 over 1 multiplied by 2 over root 3. So we need to do 12 times 2, 24, 1 times root 3. And then we're going to rationalise the denominator, multiply by root 3, multiply by root 3. So that becomes 24 root 3 over 3. So that becomes 8 root 3 as an answer. Last example. Let's label up the triangle, hypotenuse, opposite, adjacent. Highlight the sides that we're working with, these two here. And that's O and H, so this is a sine question. What are we trying to calculate? We're trying to calculate H, so that's equal to O divided by S. So that's 10 divided by sine 45, and again, I'm going to take a little bit more care here. 10 over 1 divided by sine 45. That's 10 over 1 divided by root 2 over 2. 10 over 1 multiplied by 2 over root 2. which is 20 over root 2, and then rationalising the denominator, that becomes 20 root 2 over 2, or a final answer of 10 root 2 centimetres.